Friends, let us continue with the lectures on HSC practices in offshore and petroleum engineering under the brace of NPTEL IIT Madras. We are talking about lectures on module 2. Module 2 is focusing on operational safety. Today in the 7th lecture, we are going to talk about financing risk. The question which has been answered in the previous lectures can be recollected slightly. Risk should be associated in economic terms. To get the real meaning or value of risk. So, to get the real value of risk assessment, it is essential that risk should be connected to the economic terms. Therefore, it becomes important to quantify risk. So, risk need to be quantified. One can use statistical tools to estimate probable risk analysis, but that is not effective because they do not address the economic issues behind the feeling or the real value of risk assessment. So, risk need to be quantified. We agree that risk estimates are attractive only if consequences and economic perspective are also addressed in the analysis. So, we can make a statement like this to make risk analysis or risk estimates more attractive. But if you look at the consequences, you can understand that still for consequences alone, you see that it will still remain as a statistical number. So, consequences alone can still remain as a statistical number. We will not be able to get back the original value of risk assessment if we do not attach the economic consequences or economic importance to the risk analysis. So, one is now interested to know what are those methods which can address economic loss or estimate the loss. So, one is interested in the financial implication of risk assessment. Because it should be reflected in the company's balance sheet for risk estimates and so on and so forth. Having said this, one can clearly criticize there is no single method which is capable of measuring the accident and loss statistics together. Measuring the accident and loss statistics together. Essentially, in the literature, there are three commonly referred methods used for risk estimates. One is suggested by, let us say, risk estimates, or suggested by three different agencies. One is OSHA, which we call occupational safety, and health administration. US Department of Labor, So, they also suggest methods for risk estimates. The other method, as we saw briefly in the previous lecture, is the fatality accident rate, which is also used to measure risk. The third could be fatality rate per person per year. So, this is basically an average value. All the above methods report the number of accidents and or fatalities for a fixed number of working hours. That is very, very important. So, in all the three above methods, as you see here, the number of working hours is fixed. So, depending upon the number of working hours a person is exposed to risk is what the denominator means. The number of working hours during a specific period, which is unique and of course common to all the methods. Unique in sense, the risk analysis in offshore and oil gas industries is using this specific dialogue that the number of working hours at which or during which the person will be exposed is fixed, maybe 8 hours, 6 hours, it is fixed depending upon the standards. That is a uniqueness, and incidentally this uniqueness remain common in all the three methods suggested by international regulatory authorities as seen from Srinivasan, Chandrasekharan 2015. Now, we are heading towards understanding risk in terms of economic perspective. Frank and Morgan gave a method called LRA, that is called logical risk analysis, suggested by Frank and Morgan in the year 1979. This is a systematic tool to perform risk analysis considering the economic perspective. Ultimately, one can look at a term called financing risk as addressed and stated by Frank and Morgan in the original paper. The objective of the scheme is to risk reduction. That is the objective of the whole exercise. Interestingly, Frank and Morgan advise this model to applicable to any process industry, therefore, oil and gas industry can be very well used as an applicant of this particular method. Now, before applying this method for an example problem which targets risk reduction, let us try to understand certain basic things in the administrative perspective of the whole problem. For example, I am interested in aiming at the risk reduction of the entire plant. So, I am going to apply this method or model for a process plant. The process plant may be a refinery which is on the downstream side, may be refining crude oil. The plant has got various sections, we can also call them as departments. Let us say department A, which is assigned with receiving crude oil, so inventory, stores, etc. Department B can be the processing sector, Department C could be the electromechanical control systems, etc. So, one can divide the plant into n number of departments and they can be separated depending upon their functional application related to the specific plant. So, this is very easy and very simple. This is how every industry actually works. We need not separate them, they are already separately located, isolated, interconnected by pipelines or by some flow charts, etc. So, there are interconnections between them. However, each one of them also are capable of operating independently. So, let us have a plant where such logistical arrangements do exist. So, Franken-Morgan method has actually 6 steps to compute risk analysis. So, there are 6 steps to compute risk analysis or to perform risk analysis of a given process department. In step number 1, what we actually do is each department of the plant or the industry which inherently has risk will be identified. What does it mean is each department will have inherently some risk present. The hazard scenario would be there. So, people should identify the hazard scenario and try to look at the probability of the hazard scenario getting ripened or getting matured to become a risk which is non-acceptable as per the standards of safety of the company. So, each department will be associated with a specific risk which need to be first identified. So, to do this you need to identify the hazards present in the department, and the control measures the department follow. I can give a simple example. Let us say there can be a possibility of electric fire which is an hazard. However, there are fire alarms, fire sensors, fire sprinklers, etc. located in the department which can all be counted for control measures. So, every department you can easily identify various hazards present in the department and the control measures available to counteract these hazards before they get matured to become a risk. Now, the question is if you do not have any pre-idea, that is an experience about identifying an hazard and the corresponding control measure, because I have to convert both of them into equivalent quantitative numbers mathematically. So, I have no clue, let us say I have no experience, I do not have any, I have not visited the department earlier, how do I go about it? Interestingly, if you look at the screen, you will see that the hazard groups and hazard score for each group are suggested by Franken-Morgan as a proposition. If you look at the table very clearly here, one can see, let us say the hazard group, the first group can be fire and explosion potential. Wherever there are fire and explosion potential present in the department, you can try to look at large inventory of flammables present in the department. Let us say you got a stock of cylinders, etc. If you notice there is a large inventory of flammables present in the department, then you assign a score of hazard to this group as 2. Similarly, flammables generally distributed in the department, flammables normally in the vapor phase rather than liquid phase, systems operated routinely or open routinely, flammables having low flash point, etc. So, each one of them is grouped in such a manner, and for each one of them you get assigned a specific rating depending upon some pre-accepted, pre-inspected models. So, this suggested by Frank and Morgan as a suggestive tool. However, one can also prepare this table on his own experience or based on the inventory and expertise what people have in their own industry. So, this table can be also prepared by you by conducting periodic inspection, gaining experience or including experienced professionals in the team, and one can prepare this what we call hazard grouping and hazard score. So, the grouping is fire and explosion potential, complexity of the process and so on. These are all grouping what you see in the bold letters here, and against each group what are the possible hazards present, what could be the corresponding hazard score for each level of hazard, and the value of this total hazard can be normally given in this group. So, this group can have total, if all of them are present, this group can have a total hazard score as 10 if all of them are present. If a few of them are present, can sum them up. Let us say you have large inventory present, you have systems open routinely allowing flammable air mixture, you also have flammables having low flash point present in your inventory. In that case, your hazard score for this group could be 1 plus 2 3 plus 2 5. So, against a score of 10 you can assign a score of 5 as an hazard score for this particular group. Similarly, one can also see the remaining groups. So, for each group we can calculate the hazard score, then you can add all the hazard scores for the specific group for the specific plant. So, it is very easy that hazard score. So, hazard score can be assigned to each department. So, even though do not have an experience, you can use the table or the chart given by the Frank and Morgan directly, or if you are an experienced person, you would always generate or allowed to generate your own table and the hazard scores depending upon the experience and expertise and the case studies what you have encountered in the past, recent past in the industry. So, for every department one can easily identify and assign an hazard score. So, you can group them, each group you can give a number, can sum all of them and give a single hazard score for all the groups present in the specific department. So, you will do this for each department. For example, if your plant has 3 departments A, B, C, for each department what are the possible hazard groups present, for each group what is the score, what is the total score. You can always compute this and assign this hazard score to the department A, similarly for department B, for department C independently. The next issue is about the control score. So, this is another, if you look at the screen now, you will see the remaining hazard groups like safety devices, inerting and piping, ventilation and open construction. Each one of them will have different subgroups present in them. Each one of the subgroups will have a relevant and appropriate hazard score, can always identify the respective hazard scores for each group, sum them all together to act the hazard score of the department as just now I said. Similarly, accessibility and or separation. So, all of them will have a specific hazard score. The moment you assign an hazard score, so depending upon the hazard level present in each department, you can always rank the department. So, depending upon the hazard level, you can rank the department also. It means the department which has the maximum hazardous score will always likely to contribute for the risk of the entire plant in total. So, that department is at high risk. So, you can rank the department amongst A, B, C. If the hazard score of department A is higher than that of B and C, one can always say department A is at a higher risk compared to B and C, because we assume that the hazard present in the plant A in the department A of the plant is likely to mature to become a risk. This is what we call as first level of risk assessment. Interestingly, in the first level of risk assessment itself, as suggested by Frank and Morgan, one can see here the inventory, the machinery and equipments, the people involved, the type of operation, the electrical and chemical process involved, all are accounted in looking forward for the hazard contributed from each group. So, friends, it is not only accounting for the people working or getting exposed to the risk or the hazard situation, it also includes the value of the whole process line in terms of equipments, etc. So, hazard scores are associated depending upon the commercial value of the whole process, which is indirectly accounted in terms of hazard score, and therefore, that hazard score will always rank the department depending upon which department gets the maximum hazard score first. So, one actually need a checklist to prepare an hazard score. I showed a checklist suggested by Frank and Morgan, based on which your hazard scores can be prepared. One can also prepare a checklist on their own, so that you can always assign hazard scores depending upon the type of operation practiced in the specific department, and the score can be also associated in terms of numbers related to the economical importance of the specific department and the specific subgroup within the group of the department. Okay. So, you can always account indirectly the economic perspective even at the hazard assessment level itself, which we call as first level of risk assessment. As I said, risk will always be a matured outcome of an hazard. This will always happen only when the control measures present in the department are not effective. So, to understand whether the hazard situation present in the department will always materialize to become a risk, one should also look at the control measures what the department has inbuilt in the design, so that can this control the hazard situation or not. So, one should look for control scores of each department. To maintain the control scores, again you need to have a checklist. Control scores need to be computed for each department. So, obviously, one can depend on checklist, which either you have or refer to Frank and Morgan. So, Frank and Morgan also has given the different control scores for each department or each process. So, depending upon the method by which you prepare the hazard score, similarly one can prepare the control scores also. So, now for each department one has calculated the hazard score, the control score, for understanding, let us say hazard score is nothing but the sum of hazard weightage of each subgroup within a group for each department. So, hazard score is prepared for each department. Similarly, control score is also a sum of control measures present in each department. For example, let us look into various control measures a department or a plant can have. The plant can have a siren system, the plant can have automatic shutdown system of the process line, the plant can have smoke detectors, the plant can also have, let us say, automatic sprinkler systems. All these control measures independently evaluated will have weightage, can add all of them and say the control score of my department is so and so. So, you have a control score in terms of a number you also have an hazard score in terms of a number. Both are numeric values. Now, after determining the hazard score and control score of each department, risk index can be calculated. Risk index given by Ri is nothing but the control score minus the hazard score. Ladies and gentlemen, please pay attention to this particular equation. Risk index, it is not the difference between control score and hazard score. It is always control score minus hazard score. It means risk index can be positive if the control measures are far better compared to hazard scenario present in the department. Risk index can be negative. It indicates that the control measures present in the department are very inferior compared to the hazard scenario identified by you for the department. Risk index can also be numerically 0. It means the control score numerically exactly is equal to the hazard score. So, this risk index will always indicate which department has a poor control measures, whereas the first level of risk assessment indicated which department has highest hazard present in the whole plant. So, now you are gradually converging towards a statement of concluding amongst the 7 or 8 or 3 or 4 departments present in a given process plant, which department within the plant initiates risk, which department within the plant can initiate risk, which department has the more likelihood of initiating risk, which department actually initiates or capable of initiating risk. The risk index and first level of risk assessment or the hazard score will be able to clearly tell you in mathematical terms amongst the given department which department is to be focused towards safety assurance. So, friends, it is very interesting method and very elaborate which can be applied to any process industry. Now, the catch in the whole discussion here in the step 1 is the risk index and risk assessment at the first level all depends on what we call as the inspection or a routine table. So, we need to conduct detailed inspections based on our experience and expertise of various people working in different departments. We have got to prepare this table suggested by Frank and Morgan. So, you have got to group the hazard situations present in any process plant depending upon previous yesteryear's accidents, assign score to each one of the possible hazard scenarios, make a total score, subdivide them into different groups, make a different group and keep it ready, and this can be as elaborate, as detailed as per your choice. So, your first job as a risk assessor or an offshore engineer is to make a site inspection to any process plant, note down the various hazardous scenarios present in the plant, group them, subgroup them, give a number to them and prepare an elaborate list, discuss, deliberate with the employees and employer and try to freeze it out and have a unique list with you, which itself is a very interesting and very Herculean task. Of course, interestingly, every process industry do have such lists if they are serious enough to implement assurance, safety assurance in the whole process. So, friends, in this lecture we discussed about the risk assessment method. We started with financing risk. We will continue with the same method in the next class as well and solve an example. So, we have understood that how risk is getting quantified in terms of hazard at the first level and terms of risk at the second level, both occurring at the first step itself on the Frank and Morgan financing risk analysis or method. This is one of the interesting tool which can be easily applied to any process industry as suggested by Frank and Morgan, and this method is as early as been available in the literature since 80s. So, risk analysis, friends, is not yesterday's business. People have been sensitized with risk and hazard for the past 30-40 years. So, accidents do happen, accidents happen, will happen, continue to happen even with all these methods, because accidents can be only prevented if safety and risk are realized and sensitized as an experience. So, it is a culture. So, safety is a culture, it is not a practice, not an education. Okay? So, we will discuss this method in detail in the next lecture as well. We will also solve an example, we will tell you hands on experience, we will diagnose the example very clearly and show you how this method can be very easily useful and very interestingly derivable and applicable to draw conclusions based on the scenario present within the department of a plant. Thank you very much.